So, good morning to all. Our today's discussion is mainly on distributions. As you know, we have studied two types of random variables. The first one is continuous random variable, and the other one is discrete one. Okay, continuous random variable means it will take any value in between an interval. Okay, there is a continuity. But in discrete case, the random variable will take distinct values only finite values. For example, the number of members in your family. It will be a number. It will not take fraction numbers. Okay. So such type of variables are called discrete random variables. Okay. Now we are going to discuss the distribution concept in these random variables. Distribution means the random variable and its probability distributions. The occurrence of the probability of occurrence of particular value for the random variable, or the random variable will take a value in between an interval. What about the probability? So you have already studied what is probability and you know the properties of probabilities. Okay. Now first we discuss discrete distributions. After that we will discuss on continuous distributions, because these two are two major sections. Okay, so the first thing is discrete distributions. So I share the material here. Please anybody respond whether you see the material, can see the material.
Sir.
Okay, yes. So the first discrete distribution, the theory of distribution theory is uniform distribution, or it is called rectangular distribution. Okay. So what about this distribution? It says that a random variable x to have a discrete uniform distribution or the range closed interval 1 to n. Our limit is 1 up to n. If its probability mass function is probability of x equal to x is 1 by n, where x will take the values 1, 2, etc. up to n. See, its lower value is 1, not 0. If it is 0, what happens? 1 by 0, it may it violates the properties of probability function. Okay, 1 by 0, it may be infinity. So x will not take the value 0 or infinity. These values are finite values 1 to up to n. And the distribution takes the value 0 otherwise. 0 otherwise. Okay. That means suppose x is 0. What about the probability? Probability is 0. That means it takes the value 0 otherwise. So this distribution is defined for finite numbers x equal to 1 to up to n, and its value is 1 by n. This distribution is called uniform distribution or rectangular distribution. Is it clear? So the PMF is 1 by n. It's a constant value. Okay, it's a constant value 1 by n. So suppose what x takes the value 1, then what about probability? It is 1 by 1. So it is 1. Okay. Suppose x take the value 2, then it is 1 by 2. In that way. I'm sorry, it is not 1 by 2, it is 1 by n. For any values, its probability is 1 by n, not 1 by, probability is not varying. See, probability is a constant here. Okay, probability is 1 by n. For x takes the value 1, its probability is not 1 by 1, it is probability 1 by n. So 1 by n is fixed. Okay, for 2 it is 1 by n. For n it is 1 by n. That is in that way it is defined. Okay, p of x is 1 by n. Now you know that if you have a function, then you can check whether this function follows a probability function, whether this function is a probability function. For that you have to check two properties. The first property is the value should be positive. Okay, p of x is always positive. And the second property is sum of total probability should be equal to 1. Okay, these are the two conditions for a function to be a probability function. Okay, here you know that 1 by n is positive, no doubt. Then what about summation of this probability? Summation over x equal to 1 by n, 1 by n. Summation over x equal to 1 to n, 1 by n. That means you are adding the constant 1 by n times. So it is n into 1 by n, that is equal to 1. So it satisfies the properties. Okay, so this function is a probability mass function. Okay, so this is the first discrete distribution, the simplest discrete distribution. Now we want to find out its moments, especially mean and variance. Okay, it's moment generating function, and you can study all the characteristics of this distribution. Okay, and you may try to plot its PMF also, that you can do as an exercise. Okay, you try to draw the PMF of this uniform distribution. You take x values along x-axis and the probability along y-axis and plot the points. Then you will get the shape of this distribution. Okay, then now we goes to its some properties. First one is expectation of x. How to get expectation of x? You know, expectation of x is, for discrete case, it is summation over x into p of x. Okay, summation over x into p of x. Here it is summation over x means it is the values x is 1 to n. Okay, so here what you are doing is you are just finding out the term 1 into 1 by n is common here, so you can take 1 by n probabilities outside, then it is summation I is 1 to n. That means sum of first n natural numbers, that is n into n plus 1 by 2. Okay, that divided by n, so this becomes n plus 1 by 2. Okay, then similarly you can find out expectation of x square. Expectation of x square means second row moment, mu2 dash. Okay, the first one is mu1 dash, second one is mu2 dash. Mu2 dash, similar here also, you use the formula summation I is 1 to n xi square p of xi. P of xi is constant, it is 1 by n, you take p 1 by n outside, then it is summation over I is 1 to n I square. That means summation of square terms of first n natural numbers, that is, that you know, n into n plus 1 into 2n plus 1 by 6. Here this n can be cancelled, so that expression you will get like this, n plus 1 into 2n plus 1 by 6. In that way you can find out expectation of x cube, expectation of x raised to 4, etc., but it is difficult to find out the higher moments, raw moments. Then we can easily find out the moments by using MGF. MGF, you know what is MGF? MGF is mxt, expectation of e raised to tx. You find out its mxt, then using the property, you know that relation connecting mxt and its moments. You just find out the derivatives. First find out the first derivative and put t equal to 0, you will get the mu1 dash. Similarly, second derivative, then put t equal to 0, you will get mu2 dash. In that way you can find out its moments. Okay, also the variance of x, you know the expression, that is second central moment, it is mu2 dash minus mu1 dash whole square. You have already computed mu1 dash and mu2 dash, you just substitute that values here, you will get this expression, n plus 1 into n minus 1 by 12. That is its variance. So for rectangular distribution or for uniform distribution, its mean is n plus 1 by 2. Mean is n plus 1 by 2 and its variance is n plus 1 into n minus 1 by 12, or this can be written as a plus b into a minus b, you know, a square minus b square. In that way this can be written as n square minus 1 by 12. Okay, that is its moment. Okay, that's about uh, discrete uniform distribution. Okay, or discrete rectangular distribution. Okay, now You can see the next distribution. It is called Bernoulli distribution. Okay. So what about its PMF? For discrete distribution, the probability, we are saying probability mass function PMF. Okay. Suppose X is a Bernoulli distribution. X follows a Bernoulli distribution with the parameter P. So its parameter is P. If its PMF is given by P raised to X into 1 minus P all raised to 1 minus X. P raised to X into 1 minus P all raised to 1 minus X. This is its PMF. This is PMF. Okay. Here X will take only two values. That's important. X takes only two values, 0 and 1. Okay. These are the two values allows for the distribution. Okay, that is X is a dichotomous variable. X will take only two values, 0, 1, present, absent, like that way. Okay, and its PMF is P raised to X into Q raised to 1 minus X, where Q is 1 minus P. 1 minus P is usually denoted by Q. Okay, now we can check the moments and or its mean and variance of this distribution. What about the mean and variance? For that, you have to find out its raw moments. Okay, mu r dash is expectation of X raised to R. So what about the rth moment of Bernoulli distribution? For that, here we have X will take only two values, 0 and 1. So to get the expectation of X raised to R, the derivation summation over X raised to R into P of X. Here X will take two values. First value is 0. So 0 raised to R into probability of getting 0. Getting 0 means that probability means Q. Okay, getting 1 is probability. X will take the value 1 with the probability P. So it is the derivation is like this: mu r dash is equal to this one, that is equal to P. So it's a rth moment, mu r dash is P for r equal to 1, 2, etc. What it means? It's a moment, raw moment is a fixed value. Okay, that is one of the property of this distribution. It's if you find out mu1 dash, what is mu1 dash? It is P. That is mu2 dash, it is P. So all the raw moments are fixed. It is P. Is it clear? Okay. So what is mu1 dash? It is P. Then mu2 dash, it is P. So what about variance mu2? Variance mu2 is mu2 dash minus mu1 dash all square. That is P square minus P, or P can be taken outside this P into 1 minus P, or it is PQ. Okay. So using the derivations, you can find out its MGF also. What about its MGF? MXT is, the derivation MXT is expectation of e raised to TX. Here X will take two values, 0 and 1. First put X equal to 0, then its probability. Then X equal to 1 and multiplied with its probability. Okay. So you will get this expression e raised to 0 xt into probability of X equal to 0. So that is the first value of X. Then second value of X is 1. So you will get the expression Q plus P e raised to T. This is the MXT for Bernoulli distribution or Bernoulli random variable. Okay. So using this MXT, you can find out all the raw moments, and you have already showed that the raw moments of Bernoulli distribution, it's a fixed value, it is P. Okay. Now you see a remark, the degenerate random variable. What is degenerate random variable? Sometimes we may come across a variable X which is degenerate at a point C. Say probability that X equal to 0, C is equal to 1 and equal to 0 otherwise. That means the whole mass of that distribution is concentrated to a single point. Such distributions are called a degenerate distribution. The total probability is 1. Here that probability, full probability is given to a particular point. For example, X equal to probability at X equal to 2 is equal to 1. That means the distribution is degenerate at the point x equal to 2. Full probability is giving at that point. Okay, that probability is not splitting. Full probability is given to a particular point. Such type of distributions are called degenerate distributions. Okay, for degenerate random variable, you can find out its mean and variance. Okay. uh, Here you can see that the full probability is given at a particular point, so its variance is always zero. There is no variability in that situation. So variance of x for degenerate distributions, its variance of x is always zero, because the whole mass is concentrated at that point. There is no variability. Okay. Then it's mxt is e raised to ct. Mxt is expectation of e raised to tx. That is e raised to tc into probability of x equal to c. Probability x equal to c is 1 because full mass is concentrated at the point c. So it becomes e raised to ct. So using this e raised to ct or the mgf, you can generate all raw moments. Using that, you can find out central moments. Then using central moments, you can find out skewness, kurtosis, etc. Okay, this is the way to study the properties of a distribution. Okay, that is the second type of distribution. And now we are discussing the third one, and this is one of the important distribution in the discrete distributions. Okay, this distribution is called binomial distribution. This is very important distribution, and it has wide applications in various fields. So we may come to this topic, binomial distribution. This distribution is discovered by James Bernoulli in the year 1650s. That is his span of life 1654 to 1705. So he found this distribution. This distribution appeared in 1700 and was first published posthumously in 1713 after his death, 80 years after his death. So how this distribution is defined? How this distribution is defined? Let a random experiment be performed repeatedly, each repetition being called a trial, and let the occurrence of an event in a trial be called a success, and its non-occurrence a failure. That is the binomial law. Consider a set of n independent Bernoulli trials, in which the probability P of success in any trial is constant of each trial. Then its failure is Q, where Q is 1 minus P. For example, you may consider a coin tossing experiment. Suppose you are tossing a coin and you decide that if head occurs, that is success. Suppose you are betting to your friends, you are playing a game. If head occurs, you got some return. Suppose you got 10 rupees for head occurs. If tail happens, what will the next procedure? You have to pay 10 rupees to your friend. It's a game. So when head occurs, that is a success. Okay. Tail occurs, it's a failure. So suppose you are tossing your coin n times. You are tossing your coin n times. So for the first toss, it may head or tail. Two chances are there. That is why this is just like Bernoulli trial. This is just like Bernoulli trial because two options are there, head or tail. Okay. So you are repeating this Bernoulli trial. You are repeating this trial up to n times because the game is up to n trials. So you check the outcomes. For the first toss, suppose you get H, then you denote it as S. Then second toss, it may be head or tail. Okay, there is the possibility of success or failure. So you just denote all these outcomes. You denote all these outcomes, then you can see that these outcomes are like this may be in this form: success, success, failure, success. Different combinations of this form. Sometimes the first toss you will get you may failure may occur, it may F. Different combinations. Okay. Now you split these outcomes into two groups. Two groups are success groups and failure groups, and count the success, how many success occurs, or count how many failures occurs, because total number of trial is n. Suppose the total success happened is x, small x, then failure happened is n minus x. Okay, so total is n trials. Okay, then our problem is find out the probability of, suppose you are tossing the coin a fixed number 10 times. Okay, then you want to find out the probability of x may take 5. That means your success is 5. Okay, how to find out the probability of getting 5 success? Okay, such probabilities are we can find out using this binomial distribution. Here see how the PMF of this distribution is derived. We want to find out the probability of this total trial. Okay, here you know that suppose x success and n minus x failures. Okay, you uh, collect the success first, x success, then n minus x failures. So x success means x times p. You are multiplying the probability x times. Okay, so it is p raised to x. N minus x failures, so it is n minus x. Okay, this is about a single trial. Different combinations are there. How many combinations? Because n outcomes are there. Okay, and x success happen. So this is a combination. How many ways this you can you'll get this combinations? It is ncx ways. Okay, so this probability model, it may happen in ncx ways. So you just multiply this p raised to x into q raised to n minus x with ncx. You will get the PMF for binomial distribution. This is the PMF for binomial distribution. Here p raised to x, q raised to n minus x, if n is 1, it is p raised to x, q raised to 1 minus x. What is that? It is Bernoulli distribution. Okay, so we are repeating this Bernoulli distribution n times, we will get the binomial distribution. Okay, so in the binomial distribution, if n equal to 1, that becomes Bernoulli distribution. That becomes Bernoulli distribution. Okay, so the PMF of this distribution is this distribution is defined as a random variable x is set to follow binomial distribution if it assumes only non-negative values. Only non-negative values, and its probability mass function PMF is given by P of x equal to ncx p raised to x q raised to n minus x. Here note that x can take the value 0, 1, 2, etc. n. Okay, because in n trials, no success may happen. N times you may fail. Okay, so x equal to 0 also. So x can take the value 0, 1, 2 up to n. This model is called binomial model. Okay, now you can check that whether this is a probability function. Here you know p is the parameter. This distribution has two parameters, p and n. N is number of success, number of trials. N is number of trials. N is a constant. N is its parameter, and p is another constant. That is probability of success. Okay, p is another constant. So binomial distribution is having two parameters, n and p. And you can check that whether this is a probability function. So first you have to check whether the value is always greater than or equal to 0. You check p raised to x, q raised to n minus x. You know that p is positive, so p raised to x is always positive. Q is also positive because it is 1 minus p, and that product is always positive, and cx is always positive, so the probability is always this function is always positive. And the second property is the total probability of this function. What about the total probability of this function? Total probability should be equal to 1. That you can show that you just sum this function ncx p raised to x q raised to n minus x up to x equal to 0 to n. Using the binomial expansion, you are familiar with the binomial expansion, a plus b all raised to n. Here you can see that this is a binomial expansion for p plus q all raised to n. This term is p plus q all raised to n. If you sum this function from x 0 to n, that is p plus q all raised to n. But you know that p plus q, what is p plus q? P plus q is total probability. P plus q is 1 minus p. So it is 1. So what p plus q is 1. So that summation should be equal to 1. That means this is a probability function. Okay, this is a probability function. This is about binomial model. And now next, as usual, we have to find out its moments. This is usually denoted by x follows b, capital B and p. That means x follows binomial distribution with the parameters n and p. Okay, and you may find out its mean, its variance, moments, moment generating function. These are the exercise up to you. Okay, and in the next class we will discuss some of its properties and the problems involving this distribution. Okay, so thanks to all. You may stop here now. Okay.